back to C puzzles. We're going to continue with operators 4.7 of the bitwise operator series. For those of you that are following along or are new, we are doing puzzles out of the C puzzle book by Feuer. The book is in the description of the video. Feel free to check that out. We are here in operators 4.7, the puzzle being print x XOR x being called in our main function here. So you can see here we have the print macro again, passing in the identifiers x XOR x. Now before we actually go ahead and solve and explain this puzzle, let's go ahead and see what the output is by running the code. And then afterwards we'll go ahead and jump to the solution, as well as talk a little bit about what the XOR operator is. So stay tuned. Alright, once again here we have our snippet of code opening in Visual Studio Code. You can see on line 18 we've added operators 4.7. We have the print macro passed in with the identifier x XOR x. Let's go ahead and try to compile this and see what the output is. Once again, we have GCC as our compiler, and here just passing in the executable name as well as the file name here. And now running our executable, we can see that the output of x XOR x is 0. Let's go ahead and jump to the explanation and talk about some use cases and some properties about the XOR operator. Alright, so welcome back, and we're going to jump into the solution / explanation here for operators 4.7. Again, we have three integer variables. We have integer x, y, and z in our setup. All three are initialized to 1, -1, and 1 respectively. Again, initialize them either in decimal format or in octal format. And once again, the line of code or the puzzle we're trying to evaluate is this print, passing in the identifier is x XOR x. And we can see that in this single statement we have only one operator, which is the bit exclusive OR. So therefore, of this operator, it's going to be the only one we actually evaluate, since there's not any other ones present in the statement. So therefore here, we're going to perform the bitwise exclusive OR on x and x. So once again, we just bind, have two operands, your left hand and your right hand to the operands to the XOR operation. And here again, we recap what the XOR operation is, given two inputs, A and B, and the four combinations of zeros and ones of binary values. We can see the results of C. So in this case, when both inputs are 0, the result is 0. When either of the inputs is 1, in this case for B, the result is 1. When we switch it up for A being 1 and B being 0, the result is 1. And last but not least, when both A and B are both 1, the result is 0. So we can see that when the inputs are the same, the result is 0. But when either of the inputs differ from the other, the result is 1 or true. Following that same logic here, we can see we have x being 1, and here I've shrunken it down to only capture the first 8 bits. Again, recalling that these integer values are stored as 4 bytes on a 32-bit or 64-bit machine, which I'm assuming here. Again, x repeated here, so therefore doing the XOR operation, we have 1 and 1, they're the same, result is 0, and then the remaining zeros are all the same, so therefore XORing the remaining zeros with, again, the other zeros gives you zeros. So therefore the result of this XOR operation is 0, as we saw. And then passing in the results, 0, into the print macro, we can see that once we passed in the string of x XOR x, that gets placed into the stringization per C lexicon. And again, we're going to print out the value of 0 as decimal format. As we saw previously in the output of running our code, we saw x XOR x equals 0 as expected. And before we wrap up here, I just want to talk a little bit about some common uses of XOR, where you might find them, and some properties. XORs in a lot of code both in C and C++, and even other languages use it for cryptography. A lot of cases is for encryption and decryption, you know, writing some sort of ciphers to perform some operation. They're also used for CRCs, which are known as the cyclic redundancy checks, for error detection and or parity detection. Usually these are for when you're transferring or, you know, transmitting data across some sort of medium. You want to make sure that no data is lost. You perform this CRC check to ensure that all the bits have been transmitted correctly, that there was no bit flips throughout the transmission. XORs are used a lot in digital circuits for creating half adders, full adders, which are a combination of logic gates put together to perform a lot of arithmetic operations. In terms of programming, you can use XORs to do a lot of little cool, neat tricks. One of them being you can, you know, write an odd even detection, determine how many determine if the number is odd or even depending on the number of bits in its binary representation. Some common properties of the XOR include that given a value x, XORed with 0, you get the value of x itself. So you can see here that we've got a clear transparent property that regardless of what the value of x is, XORing it with the value of 0 will give you back the result here. Another cool property is that x, XOR itself, will always equal 0. So therefore, if you had to kind of, you know, set some sort of number to be 0, you can just XOR it by itself. Ideally, you can go ahead and subtract x minus x to get 0. And sometimes when compiling some code in terms of optimization, the compiler may be able to replace, you know, the subtraction instructions with the XOR, but that is not the case. That's going to be up to the compiler. Another last but not least, another property here is that you have given two values x and y, and you're going to XOR themselves. That's cumulative, saying that's the same thing as y XOR x, so therefore the order swapping does not matter. The XOR value of x and y swapped is the same thing. There's a few more properties regarding to XOR, and I'm going to link that into the description, a little fun article to talk about more use cases of XOR. So feel free to check that out. Alright everyone, thank you again for watching. To watch the previous video, go ahead and click on the bottom left hand corner here in a bit. To watch any of the previous C puzzle videos, go ahead and click on the playlist. It will show up in the middle and the bottom of the screen. And to watch more videos related to C puzzle programming, to wrap up this section of operators for bitwise operators, go ahead and click on the bottom right hand corner and click subscribe, and I'll catch you all in the next video.